Why speculation is bad in software. Sandi Metz. I'm Chris Tennis. I'm a KMP developer, tech support. So they're coming out to close that on Tuesday. I hope so. So there's someone watch this. I haven't watched this video yet. I think I've seen this. I've watched this conference that she was at. And I give Dev Tools Made Simple, like and subscribe. He's like bringing all these little clips out, which is great. But I have mixed opinions about her because she did this thing about object oriented programming that was just a muddled mess. I don't know if the copy is still up there, but I watched it. I was like, what is this? So she's using Ruby. I was like, I just think she was just trying to over engineer object oriented stuff where it really didn't belong. The best stuff that object oriented programming is really good at is for anything that's simulation or can be modeled as a simulation. Lots of individual actors all moving around, stuff like that. So, but most processes are just like start, process the thing, end, output someplace, get the input from somewhere, do some process, and then output it someplace. So it's not this big simulation thing. It's just do the processing thing. All right, so I have not watched this yet, but let's just watch it together.
Who in here has ever written some code for a feature you thought might arrive in the future?
Of course. I mean, yes, that is the classic error. We do this at least once in our career, thinking we can cut it off at the pass, and sometimes we're right. We'll get oftentimes it'll be kind of in the ballpark of what we're doing, but there'll become a point where it's like, I can imagine all future scenarios. This is like the standard mid-level senior philosopher developer. I can see the future. I know where this, and you might guess a couple times right, and that's what the guys get the worst, right? They can get this, then they want to do all of it. It's like you're not gonna be able to fill that space, that Hilbert space. You're not gonna fill it, man. And they just think they can. It's like you're fool's errand. Let's keep going.
Keep your hands up for a minute. All right, I'm going to out myself with you here.
Of course.
Who in here has ever, after many months of working around that code, ripped it out and thrown it away?
Yes, or started over. That was a bad idea. Just write what we need right now. Think a little bit ahead. Like have the problem space that you're trying to solve, but don't like try and go overdo it, man. You're just gonna shoot yourself in the foot anyway.
Okay, we are bad guessers.
We're terrible.
And I love OO. I love object-oriented design. It's a thing that's really interests me. But this thing of speculative generality, where we say, I'm going to do something really cool in my code for something.
This is not an OO thing. This is just a human thing. This is a human thing, planning thing. We think we can plan stuff. We might get it right sometimes, and then we think we can do it all. It's like, oh man, it's an ontological problem, a epistemological problem, where we think we can cover the space. And it's like, no, you might get lucky, but no. In a general case, no.
Feature that I think we might need later. This is why people say bad things about OO, right? This is what they blame us for. It's primarily things in that category.
Well, it's not OO. It's not. That's not. It was happening way before OO. So don't blame OO. We can blame OO for other things. That's for sure, but not that.
You have to be right. So the few times that you are right have to really be big wins to outweigh the enormous cost of being wrong. Code is read many more times than it is written.
Definitely.
The reason that we cost money is the time we spend.
I love the source code. It's a dev tools just randomly puts in there, no explanation, or it's got some Java here for doing some equipment class of some device where it gets a formatted list of values for this general manager of this piece of equipment. Okay, interesting.
Reading code, and if you add generality, you increase the level of abstraction of code. Very often that means adding levels of indirection, which humans are terrible at.
Well, I mean, so you have to do it if you want to decouple stuff, right? This is the trade-off. Either you go indirect or you have to decouple it and have a joint there that you have to manage the joint now of the interface between the two things. You're just kind of deferring it. You're pushing the problem space down one level.
It means that every time someone looks at that code, it's harder to understand.
True.
So we should really try to restrain ourselves and not speculate about the future. When the new requirements come in, they'll tell us how we wish we'd written the code, and we can do it then.
Right. If you've designed the system to set it up to do that way, yeah. If you got a flexibility enough in there and kind of understand the problem space enough, had a product market fit enough where you can kind of see where things are headed and maybe plan for that. But in general, there's no way you're gonna know. You're always gonna have to just get to the point where it's like, oh, we'll just okay. We're gonna now. This was a great set of experiments. We learned a lot, guys. But it's time to start a new set of experiments and have the guts enough to do that because your competition will eventually do that for you if you don't. You know that. Give me a like and subscribe, and I'll continue my ranting.